In this video, we are going to talk about identifying numbers of carbon atoms, and this is going to be under optical isomerism. I just want to use this video to explain how to identify the chiral center and how to calculate what numbers of stereoisomers in which what a chiral molecule have. So you really want to stick to the end of this video. So many students still have issue with this kind of questions. So I want to use this video to explain everything to you. Now, if this video is helpful, always give it a like and comment your thought at the comment section. How you follow through what I'm going to do in this video here, please always give it a like and comment at the comment section. You can also share this video to your friends or classmates who you think will need this type of content here. Do you get that? So let's get into it. It says draw the structure indicating the chiral centers with asterisk and calculate the total numbers of stereoisomers. Therefore, what's a chiral center? A chiral center or a chiral carbon is that point or carbon that is having 4 different groups. A good example is here we have X, Y, Z, A. Now, whenever a carbon is having 4 different groups attached to it, this carbon is known as what? Chiral carbon. Right there. Or you can say asymmetric carbon. Asymmetric carbon. Or you can say stereo center. Stereo center. Do you get that? They always say it can either be what? A chiral carbon or a chiral center, asymmetric carbon or asymmetric center, or stereo center, whichever way you want to call it, or the way they put it in the word exam. So another thing you want to know that is that the numbers of stereoisomers in which a chiral molecule have depends on the numbers of our chiral center. Do you get that? So numbers of stereoisomers is equals to what? Equals to what? 2 raised to what? N. Where n equals to what? Numbers of chiral center. Do you get that? It's very important to know this in here. So when a carbon have 4 different groups, now chiral carbon or chiral center or stereo center or asymmetric center. Do you get that? So for that numbers of carbon atom or chiral carbon, you know what numbers of stereoisomers in which what a molecule will have. I'm not going to go into enantiomers, diastereomers, racemic mixtures, and yes, all those other terms about what it calls optical activity. I only want to show you this question here, so pay close attention. So here you say 3 pentanol. So before you can actually identify the numbers of chiral center or the chiral carbon, before you must draw the word structure. Do you get that? As organic chemistry students, you must know how to draw the structure from the IUPAC. So you have been giving all these IUPAC what's name. If you are still having issue with what nomenclature of the organic compound, I have a complete playlist of what alkanes, cycloalkanes, ketones, IDI, carbonic acid, and the various functional group here. I will leave the link at the description below where you can access a complete playlist. And I've done a complete video I can use the IUPAC name to draw the structure of an organic molecule. So you can go check out that video by the end of this video here. So here we have 3 pentanol. Therefore, let's draw 3 pentanol. Pentanol means we talk about 3 pentanol. Now this one here, pent means what? 5 carbon atom. 1, 2, 3, 4, 5. Are you there? And OL means what? Is an alcohol. This 3 means that the O is our carbon number 3. So here we have 1, 2, 3 OH. That means that here we're going to have hydrogen, So therefore you need to identify. You must not draw this structure. Do you get that? So from here now, let's identify the chiral center. or chiral carbon. Remember I told you that a chiral carbon is that carbon that have 4 different groups or atoms or elements attached to it. So if you look at this first carbon here, this first carbon cannot be a chiral carbon. Why? Because having what 3 hydrogens, so it's at. This guy cannot have what a chiral carbon. No, it cannot be a chiral carbon. Why? Because I have what 2 hydrogen. Now before I look here, let's look at here. Here cannot be a chiral carbon. Here cannot be a chiral carbon. So our point of focus is going to be at this point here. So basically, we say that it's a chiral carbon. Now, but now let's focus on this carbon. Let's see if it's a what chiral carbon. Look at, so you can rejoice one to be what CH3, CH2, right? This one is what CH2. Here is what CH2. The carbon OH, hydrogen CH2, CH3. Now these two are different, right? But you see these two things here. These two are the same because these two are the same. This carbon cannot be a chiral carbon. Do you get that? It means that this molecule there is no chiral carbon. Do you get that? Because there's no, the molecule does not contain carbon that are what 4 different groups. If you look at this one here, this carbon contains what an ethyl, what an ethyl group. So no chiral carbon. Do you get that? If there's no chiral carbon, there's no what stereoisomer. So this one is out. So no chiral carbon. So we need to wipe it out. The next thing is what? The next here is what 3-chloro-1-butene. 3-chloro-1-butene. So look at it very well. 3-chloro-1-butene. So now let's see if this molecule is going to have a Chiral center right there. So butene means what? There's a what double bond, right? So here we have 1, 2, 3, 4, right? So you can say 1, 2, 3, 4, right? Now when we talk about 1 butene, that is the double bonds are coming about what? 1. Double bonds are what coming about what? 1. And when we talk about 3, that is chlorine are coming about what? 3 here. So now let's give them hydrogen. Now so we're going to have what 2 hydrogen. Why? Because carbons have 4 bonds. So they must have what 1 hydrogen. You must have what 1 hydrogen. 1 hydrogen, 1 hydrogen, 1 hydrogen. Do that. Now remember, any that have double bond, any carbon that have double bond is already total is what at already. So these two cannot be considered atom because there's a double bond. Do you get? So now the 2 carbon atom you want to look at is this guy and this guy. This cannot be a chiral carbon. Do you get that? This carbon here cannot be a chiral carbon because it has 3 hydrogen. Do you get that? But now let's look at this one. Let's look at what this carbon here, this point here. Now it can also be written as CH2 double bond CH and C hydrogen. Then what Cl CH3. Now when you look at this carbon here, look at this one. Look at this. Look at this. Look at this. You can see that this carbon is having 4 different groups or 4 different groups of an element attached to it, right? Chlorine is different from this. This is different from this, and this is different from this here. Now, because this is a chiral molecule or chiral carbon, This is what is a chiral carbon. So it has what 1 chiral carbon. It has what 1 chiral carbon or 1 stereo center or asymmetric center. Hope you understand. Please, you are following. If you are getting value from this video, comment at the comment section that you are following and you're actually enjoying this video. It goes a long way to tell me that you're actually not following this video. Do you watch this video? Just go like that without commenting or liking this video. Please always like because it goes a long way to what make YouTube to what spread this video to other person. We are trying to see how you can get 3,000 subscribers before the end of this month. I don't know how I'm going to get that because I really want to reach more students who chemistry is actually what their issue. So now, since we have 1 stereo center here or chiral carbon here, now let's calculate the numbers of stereoisomers is going to have. So with the numbers of chiral carbon, let's get what numbers of stereoisomers. Remember I told you that numbers of stereoisomers, number of what stereoisomers equals to what 2 raised to what n. N means what numbers of chiral carbon, right? So my n is equals to what 1. So numbers of stereoisomers is equals to what 2 raised to what 1, which is what 2. It means that this guy is this is example of two stereoisomers. You get? So in my next video, in my future video, I'm going to teach you enantiomers, diastereomers, and I'll teach you how to use the Fisher and percentage formula to draw enantiomers. So you want to watch out for that video. I don't talk about too many things in this video. I just want to show you how to identify what numbers we call carbon and the numbers of stereoisomers what the carbon molecule possess based on the numbers of carbon possess. So this one only have one carbon right there. So the number of possible stereoisomers is what? 2. So let's move to what? To the C. You can pause the video and do C for me and see if you can get the answer. Pause the video. How many stereoisomers would this one have? Pause the video and try it for me. How many carbon and how many stereoisomers will this one have? Pause the video and we'll try it for me. I want to see what you can do. So let's look at it here. We have 3 phenyl, 2 butanol, 3 phenyl, 3 phenyl, 2 butanol. Right there. 3 phenyl, 2 butanol. So let's draw the structure first. But means what? 4 carbon, 1, 2, 3, 4. So here we have 1, 2, 3, 4. I count about 2, I have what? My OH. That is the functional reason I will count about 2. I count about 3, I have what? A phenyl. A benzene. This is called phenyl. So the next I want to do is to give what? My hydrogen. Here we have hydrogen, 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 what? And hydrogen. Do you get that? So it means that let's figure out the numbers of possible stereoisomers. Now let's figure out the numbers of Chiral centers this possess. Now this cannot be a stereoisomer, so we're going to do CH what? 2, right? Is this a Chiral carbon? No, it's not a Chiral carbon because why? You have what? 3 hydrogen atoms. So here we have OH, here we have what? H, here we have H, here we have what? The phenyl, here we have CH3. Now this is a Chiral carbon and this is what is a Chiral carbon. Look at because this carbon atom here is having OH, hydrogen, and this one here, and this carbon here. So it's totally what different. So when you look at this carbon here, this carbon carry 4 different groups. The whole of this guy, the whole of this one, this and this here. So here the Chiral carbon. The same with that one here. This one is a Chiral carbon because it's carrying hydrogen, a methyl, a phenyl, and the whole of this carbon here. Do you get that? So we have what? 2 Chiral centers. 2 what? Chiral centers. 2 Chiral centers. 2 Chiral centers. So my N is equal to what? 2. So numbers of possible stereoisomers. Numbers of stereoisomers. Isomers is equal to what? 2 raised to 2, which is what? 4. Because it's going to be 2 times 2, right? So it means that this compound here, which is what? 3 phenyl, 2 butanol, have 4 possible what? Stereoisomers. Like what I said in my future video, I want to teach you how to draw the possible stereoisomers. Do you get that? You don't want to miss out that video. That is why you need to subscribe to the channel so that you're not going to miss out any video content. Always follow me closely. Always follow me closely on YouTube and on TikTok. Always follow me closely because we are trying to build a community where I'm trying can possible best what actually see how I can be of help to people who really what who are actually having issues with what chemistry, because I know how tough chemistry look like when you don't have the right person, especially when you are doing it by yourself. How difficult it's going to look like. Do you get that? Now, what brought me here today is a lot of videos I watch on YouTube. So I want to give it back to people. Now, let's look at what the third one. You can also pause the video and do the third one. 4 amino, 4 cyno, 3 nitro, heptane. Do you get that? 4 amino, 4 cyno, 3 nitro, heptane. So go ahead, try something. How many carbon does it have? And how many possible stereoisomers is it going to get? Pause the video and do it for me. So now let's do it together. Now, when we talk about heptane, heptane means what? 7 carbon atoms. So here we have 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7, right? So now let's start them from here. 1, 2, 3, 4, 5, 6, 7. So I count about 4. I have amino group. So here I have NH2. 2 years. Then I count about 4. I have a cyno group, which was CN. Can you see that? Then I count about 3. have a nitro group. Here we have NO2. Do that. The rest is going to be hydrogen. So here we have hydrogen, 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 hydrogen. Here we have hydrogen, right? Hydrogen, 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 hydrogen. Here we have hydrogen, hydrogen, what? Hydrogen. Can you see that? So it's obvious. So here we have CH3. Here we have what? CH2. Here we have C, hydrogen, and what? NO2. Here we have NH2. Here we have what? CN. Here we have CH2, CH2, CH2. Can you see that? So now this is a chiral carbon and this is a chiral carbon. We only have two chiral carbon, which is the word isomers. You got so because this carbon atom is having 1, 2, 3, and 4, and this carbon is having 1, 2, 3, and 4. So we have what two chiral carbon. Do you get? So how many possible stereoisomers am I going to get? How many possible stereoisomers am I going to get? Yeah. So numbers of stereoisomers, isomers is equal to 2 raised to what? N. My N is equal to what? 2 because numbers of stereoisomers. So the numbers of what? Chiral centers is what? Is 2. So that will be numbers of stereoisomers is equal to 2 raised to what? 2, which is what? 4. Do you understand? So I believe this video is helpful. If this video is helpful and you follow up throughout this video, you just say understood and you follow through this video. I really want to hear from you. If there's any video topic you want to do, please try and comment in the comment section. Now, if you are still having issues with how to draw organic structure, now you can see some set of videos here, or how to name organic compound. You can see some set of video here. You can go check out those videos. Thanks for watching. See you in my next video.